Hello everyone. Okay, so in this video, we are looking at the margin of error and confidence intervals. So, in statistics, we can never really find the actual mean of anything we study. If I want to conduct a study on secondary school children and I want to find their mean heights of second year students, I will have a very hard time of calculating that. Right? But that is where margin of error and confidence intervals comes in, because I will be able to make a region or a range of values in which I'm 95% sure that the true population mean lies within. But before we get into that, let's just recap some things. So we're looking at population and sample proportion. So recall, the population is the entire group being studied. So population doesn't mean like, oh my god, everyone who lives in Ireland. No, population just means everyone who you are studying within a study. So if you are studying secondary school, if you're studying secondary schools, you are conducting a study. The population is every secondary school in Ireland. So for example, like down in like Galway, Louth, Westmeath, Longford, like every single secondary school there, you're like, that is my population. But it is not practical. It's not practical to conduct a study on that many schools. There's too many of them. So that's why when surveying, we often take a small itsy bitsy part of my population and we call that the sample. Right? So in statistics, we love a sample, right? We love a sample. So what a sample just means is I have my population here. Here are all the things that we are studying. So this is all the secondary schools in Ireland or something, right? But I'm like, oh god, that's too many of them. So we take a sample. So I might only look at like 4 of them, right? But hopefully if you take enough sample and a representative sample, if you take enough people for a sample, you will have a very good idea of what the rest of these schools are going to be like, or the rest of my data points are going to be like. So, a sample can give an indication of the whole population. In this section, we will meet population proportion and sample proportion. So, often sampling is done in order to estimate the proportion or fraction. Proportion is not a word for fraction. The fraction of a population that has a specific characteristic, such as the proportion of students who study medicine. So say for example, we are looking at students who study medicine. That the fraction of students that study medicine. So my population is the secondary school students of Ireland. I am studying them and I want to find out what percentage of them went on to study medicine. So the population proportion is denoted by P. So P for population. And the sample proportion is denoted, well, I was meant to note it here, P hat. So a little P hat. Thus, if in reality, oops, I made a mistake here. Ignore me. Thus, in reality, 10% of students, if actually 10% of students, went on to study medicine, my population proportion is 0.10 or 10%. Right? If 10% of students went on to study medicine, my population proportion is 10%. That's how many of them went on to study medicine. But unfortunately, we can never find the exact value of a population proportion. We can only estimate. That's why we look at sample proportion. So say, for example, we did a study. We did an exit study of 100 6th-year students and asked them, hey, what course did you get into? And we looked at a study of 100 students and 10 said to us they went to go on to study medicine. Therefore, the sample proportion is, well, 10 out of the 100 in my sample study medicine. Therefore, 1/10 of my sample proportion, or 0.1, or 10%, or 1 over 10, right? 10% of my sample went on to study medicine. That's my sample proportion. So my sample proportion is just the fractional percentage of my sample with this characteristic, and then my population proportion is just the fraction percentage or decimal or whatever of the actual population who have this characteristic. So remember, very important, p hat is only an estimator of my population proportion. P hat, so p hat, we call it p hat because it's p and it's wearing a little hat. That is only ever going to be an estimate of my population proportion, right? So it's never going to be 100% accurate. My sample proportion, so the data I collect from my sample is never going to be 100% the population proportion. But we'll soon find out we can manipulate it and get a 95% accuracy. So now we're looking at the margin of error. So if many of you go on to college and do papers and studies, or maybe you open up the Irish Times or something and see the studies conducted, it will tell you what the margin of error is. And the margin of error is just a little wiggle room. It's just a little wiggle room we have, right? So you know how you say like if someone asked you, oh, how much did your dress cost? I was like, oh, I think it was like €20, give or take an extra 5, so give or take. So it could be €5 more, it could be €5 less. That's what the margin of error is. So when surveying, we have to account for some error. We have to account for an error within our surveying. Surveys are rarely 100% accurate. So the margin of error can tell us how far off our answer could be from the true value. So the margin of error is here, 1 over square root of n, where n is my sample size. This is not in your log tables, so make a note of it. You have to learn this formula off. So note, the bigger my sample, the smaller my margin of error, and that makes sense. That makes sense, right? If I survey 1,000 people, that's going to be way more accurate than me surveying 10 people, right? So let's look here. If my sample size is 400, so if I surveyed 400 people, or there's 400 people in my sample, my margin of error is going to be 1 over square root of 400, which is going to be 1 over 20, which is roughly equal to 5%. 2,500, that's going to be 1 over 2,500, which is equal to 1 over 50? We'll check. I think it's 50. No, it's not 50. I do not know my fractions. It is 50. It is 50. Shucks my instincts. 1 over 50, that's going to be equal to 2%. Now, 360,000, that's going to be 1 over root 360,000, which is 1 over 600, which is roughly going to be equal to 1.6%. Right? So what's that mean? If my sample size is 400, that means I have a margin of error of 5%. So if my sample size is 400 and I calculate my sample proportion from that, that means give or take an extra 5% the actual true population proportions here, right? 2,500, right? Whatever answer I get here from my sample portion, give or take an extra 2%, right? Same here, 360,000, right? 1.6%. So give or take an extra 1.6% of my to my sample proportion there. So that is your that is what margin of error means. So let's combine all these together now with 95% confidence interval. So this is what we do primarily as statisticians, right? We love a confidence interval. So we may use the margin of error to find an interval within which 95%, which we are 95% confident that the true population proportion lies, right? So I'm able to construct now, if I study a group of people, say I study a little group of second years and I found their mean height, right? And I say I studied 200 of them students, right, and get my margin of error, I am then able to add on and subtract. I'm able to add on and subtract 2%. So write down. So let's look at a question here, right? So actually, what is sample proportion? Sorry. So what it just means is here, right? This is not in your log tables again, so make sure you make a note of this. So p hat, so sample proportion minus my margin of error is less than p, the true population proportion of the actual like answer. If I was to like actually survey every single person, right? If I was that is what the answer would be. I know that is going to be more than this, but less than my p hat or my sample proportion plus my margin of error. So this means 95 times out of 10. P, my population proportion, will lie in this interval. We are never absolutely certain of anything in statistics. We are never certain. We can never say with 100% confidence something lies within this interval. We are only ever 95% sure. Well, you could be more if in a higher if you do higher level maths. We extend to more confidence intervals, but for the purpose of this video or in the order level course, only 95%. So let's do this example here, calculating a confidence interval. So a random sample of 500 people are given a COVID-19 vaccine, and 85 have experienced some discomfort. Write down the sample size. So what is my sample size? My sample size is 500, right? Because I surveyed 500 people. Calculate the margin of error. Well, that's going to be 1 over root n. That's 1 over root 500. That's going to be 1 over, I don't know. That is going to be roughly equal to 0.045 or 4.5%, right? Find the sample proportions of p hat. So in my sample, how many of them had discomfort after the vaccine? Well, 85 out of 500 had discomfort from the COVID vaccine. And that is going to be equal to 0.17 or 17%. So 17% of my sample has some discomfort with COVID, the COVID vaccine. Find the confidence interval. So I want to now make an interval, right? So of values for which the true population proportion can lie. So that's going to be p hat minus my margin of error 1 over root n is less than p, which is less than p hat plus 1 over root n. That is going to be 0.17 minus 0.045 is less than p. Don't touch this. Which is less than 0.17 plus 0.045. So my left hand side now should equal to 0.125 and my right hand side should equal to 0.215. So, or if we change them to percentages, 12.5% and 21.5%. So what does this mean? This just means I can say with 95% confidence, I am 95% sure, I can say with 95% confidence that if that between 12.5 and 21.5% of recipients of that COVID vaccine will have some discomfort associated with it. And that is the confidence intervals. So in my next video, we are going to be now continuing on with this, and we're going to be doing hypothesis testing using our confidence intervals to test claims. And if this video is any help, I hope it's some help, and I'll catch you guys later. Bye.